All right, folks. So for the last video of our nuclear decay video question series, we're going to be looking at graphing nuclear decay. So when we graph nuclear decay, we have to remember that we're dealing with protons on one axis and neutrons on the other. We are not given the number of protons and neutrons in the question. All we're given is the isotope form. So as a reminder, I'm going to write down in this little empty space. The way that we do this is the name of the element dash the mass, which is our protons plus our neutrons. So we know the total number of protons and neutrons here, but we don't know how many of each we have until we use the periodic table. So one thing I'm going to try my darndest to do, and I think I have the right number of colors with me, is do each of these dots in a different color just so it's easier to see them when they're graphed. And I'm really hoping, because I know this paper looks a little bit blue in this video, that it transitions okay. So I'm going to do AT208 in black. I'm going to zoom in for right now just so we can solve them all out, and then we'll plot them all in a second. For AT208, I know that my protons plus my neutrons make up my mass number, which is 208. I can use my periodic table to find AT. AT, astatine, is number 85. Remember, that number 85 tells us the number of protons. So when I go to do my math here, protons equals 85. I can solve for the number of neutrons. Okay. So our neutrons here, it's 123 neutrons. I'm actually going to write that down in my little notes area too, that your neutrons equals your mass number minus your atomic number. So I know my atomic number. My number of protons for this guy was 85. This is not the greatest graph, and I do apologize, you guys. I'm not the designer of this graph. So I'm going to give it my best shot, right? For number 85, I'm going to go over just a little for 82, and I'm going to go up to 123. So I have that falling like right in here. That one, right, this gets tricky. I would call either beta plus decay or alpha decay. On mine, it's pretty clearly beta plus, but I also know that if you didn't graph exactly how I graphed, you might have a different answer, and that's okay. Right? As long as your point fell about where my point fell, I'm happy with that. Let's take a look at another one. We're going to do K42. K is potassium, so this is potassium 42. We know that that 42 is the number that represents the mass, so the protons plus the neutrons. I'm going to look on the periodic table, and I see K, potassium, is number 19. So protons equals 19 here. Do a little bit of subtraction. I get 23 neutrons in this one. So I'm going to go over, find about 19 protons. Again, between 14 and 28, it's not superbly easy to put 20 somewhere on there. I'm going to put it just a little to the left of center. And then I'm going to go up to 23 neutrons. So when I plotted that, well, maybe I plotted that, I have it falling in the beta plus range, but I also could see it landing in stable. This is so funny. I'm looking at my key right now, and on my key I went way closer to 14 and had it up here. I actually think I like the second placement better. I feel like that's more truly like where 19 would be in that span. So let's go with beta. Let's go right here where the star is. And let's go beta minus on this one. Would also take beta plus though. Remember, if your graphing makes logical sense, I'm going to take the answer no matter if you're right or not. Let's take a look at thorium. All right. So for thorium-229, here's what we're dealing with. We know 229 is what combination? That's right. It's still protons and neutrons. So I'm going to just write mass here, I think. I know that my protons can be found on the periodic table. So go ahead, check real quick and see if you can find thorium before I do. It's in the bottom row. Thorium is number 90. So I'm going to write that down. Do my little bit of subtraction. Should leave you with 139 neutrons. So I'm going to go over 90. Up 139. This is so hard figuring out where I want it to go. Trying to like roughly scale this with the distance for 14. I think that I'm going to put it like right here. Oh, it's hard to see if it's not on the screen. So this one right here is thorium. This one I would take any form of decay. Just put it where it lands up. I have this as alpha. I will also tell you I did Google this one. This one is alpha for sure. But again, if you have yours somewhere else, I'm cool with it. Up until now, we've primarily looked at some that have these like really close to the edge ones. I'm telling you right now on the test, it will not look like that. All right. So, pick up my next color. Let's do PO210. That's polonium-210. So, polonium, we have 210 is the mass. Polonium is in column 16 on the periodic table. Remember, your columns are labeled on the top. I'm going to go all the way down just to find out polonium's number 84. Do a little subtraction to find 126 remaining neutrons. Here's the beautiful thing about it being 126 remaining neutrons. The graph for that is actually super easy. Because check that out. There's 126 in a straight line. Love to see it. Makes our lives easy. So we're going to go over to 82. I'm basically going to go up on the line for 82 and then just go over a little bit. That one to me also looks like alpha decay. But I could also see the argument, honestly, for any form of decay here. Our last one. Oh my gosh, sorry. Someone else is filming a video on the other side of the wall and it just said, hey there, and it spooked me. All right, this one is promethium. Promethium is element number 61. Okay. I'd like you to try promethium without me. Go ahead, pause the video and we're going to check back in together in about 3, 2, 1. All right, so for promethium, here's what I have. I have a mass of 165. I just told you that this thing has 61 protons. When I do that subtraction, I get 104 neutrons. From there, I'm going to go over 61 protons. So I'm going to go 50 plus a little bit. Then I'm going to go up 104. And that's going to put me pretty firmly in our beta negative range, beta minus, okay? I'm telling you right now, the one on our more formal form of assessment, our test, is going to look very similar to this promethium example. It's going to be really clearly in the middle of a type of decay. You will not be able to make a wrong guess on it. Okay? I'll also tell you on the test, there's big circles, and if it lands in a certain circle, we're just going to tell you right away, oh, that one's alpha, that one's beta. It will make this a little less stressful. If you feel like you did pretty well with promethium, if you feel like your confidence is decently high after watching this video, then you have nothing to worry about on the test. I hope that this series has been helpful for you, and I look forward to seeing you on YouTube as we continue down the school year together. Bye-bye.